Okay, another issue with regard to developing project schedule is basically to get the duration of an activity. The issue is that how do we get the duration? Okay, so normally in order to develop a project schedule, what you need to do is basically develop the WBS system. From WBS system, you will come up with the list of activities. Then the second one is basically automatically you will get the logical relationship out of this WBS. But then the issue of duration of the activity that you listed, okay, from your WBS. So how do you get this duration? Is it by assumption? You just simply assume, let's say in one situation, if you are the contractor, you will get a project from the client. Client normally set the contract period for a project. So basically you have no choice. Okay. Then basically you need to squeeze in all the activity that you already planned into the project or contract period. Let's say the contract period is 2 years, then you have to squeeze in everything. Yes, it is true that you need to squeeze in, but the issue is that how do you identify or basically set the timing for each of the activities, such as piling. Let's say piling, you set 10 days. Is it just simply by setting, just simply assume it is 10 days or what? This is the issue. Okay, activity duration and project duration is a different thing. For instance, activity duration is like this. When you divide the activity, it is like A, B, C, D, E, and F. That is basically what we call activity duration. And at the end of the day, let's say F, you will know one thing. This is what we call project duration. Project duration is basically the whole time frame in order to complete a project from the beginning until the end. That is what we call project duration. So project activity duration is the subset, okay, subset of the what we call project duration. In order to know project duration, you basically need to know the activity duration. Then from the way you arrange or put those activity in order, then only you will know the project duration. And how do you know the project duration in a network diagram? Well, you can only know once you connect those activities together, okay? And in a network, then only, because sometimes activity can be overlapped. It is not like uh, all the activity have to do in so-called finish to start manners. No, no, no. Sometimes they are being overlapped. Sometimes they are being done concurrently. So you might have 1,000 activities, but since you overlap some of the activities, you can manage to complete within 2 years. Okay, it looks like as if you cannot complete 1,000 activity in 2 years, but once you arrange them in a proper manner, then you can achieve those things. Okay, so setting the or getting the activity duration is basically through maybe your past experience. Your past experience meaning to say you need to record or put them into a database. Then only you can recall back those things. And even if you record those things, this record basically it was based on a project. previous project. And a current project might not basically be exactly the same as the previous project, because there are so many what we call factors that determine the what we call the execution of a certain project. Okay, it depends on the man, machine, material, or even technique. It depends on the weather condition, the soil condition, many factors. But anyway, we need to have some kind of base. Otherwise, it is very difficult to refer. Okay, so I would say, even though it is based on past experience, we simply cannot rely 100%. We just need to do some kind of adjustment, but it is okay. This is what we call planning. Planning do have some kind of what we call some what we call guess, okay, estimated guess. It might not be accurate, but at least when you base on certain facts and figure, it could be okay. Arithmetic computation, of course, anything that you need to compute, okay, using standard guide, which is in USA, means, I think there is a publication called means standard guide or something. In USA, they do publish. In Malaysia, officially, we have not seen any publication from relevant authorities. They do give a little bit of information, but it is not going to be comprehensive. I know certain organizations like CIDB do release some publication, but it was not meant to be comprehensive. Arithmetic computation, compute. How do you compute? Again, from the concept of productivity. Okay, productivity rate. What is productivity rate? It's output over input. Output is equivalent to quantity. So that's why when you want to do scheduling, you need to extract the quantity, or the quantity is simply given in a BQ. But if, for instance, it is given in BQ, again, BQ sometimes they put it in what we call in lump sum manners. They put everything together. Whereas when you do scheduling, you need to break up. Okay, you need to break up the amount of work according to a more manageable things. Every day you only manage to do certain portion of the work. So even BQ is given, but still you need to break up the BQ according to the logical sequence of work. So this is the issue with engineer. Why engineer basically need to learn taking off, etc., etc. Well, because we need to use those what we call quantity in our scheduling. So BQ normally being done by QS in Malaysia, but the issue is that QS do not do scheduling or planning. The planning and scheduling is the responsibility of engineer or managers. That is the issue. So that's why we need to know the fundamental of taking off, etc. And then quantity divided by input time. Okay, time. And then the unit can be according to whatever unit. Concrete could be different, formwork could be different, etc. Okay, let's take one example. Painting work. Painting work as one of activity. Painting work is being done manually using one laborer. Let's say that laborer can do work in 10 square meter of painting of the wall in 1 hour. So this is what we call productivity rate, or some publication put labor constant. Labor constant. Okay, so productivity rate, labor constant. For the machine, they call it machinery output, is the same thing. Okay, what is constant? Once you have the something divided by something, that is what we call constant. Okay, painting work. And let's assume you are given a job, or you have a job to do. Painting the whole wall, which is equivalent to 1,000 square foot, no, meter square. Okay, so that is the quantity of the whole wall. The question is that you want to know the timing. How many days? How many days we need to hire this guy, laborer, to do the painting work? Okay, that is the days, meaning to say duration of painting work. So how to solve this problem? Again, go back to the equation Q over T. Productivity is equivalent to Q over T. So Q is 1,000 that we want to know. T is unknown. And how about P? P, this is a P that belong to whatever trait that we are trying to relate to. And you see, the unknown is the T. Once we do some mathematical equation, so T is equivalent to 1,000 divided by 1 hour. And you notice that the unit will be cancelled out. Okay, what's left is 100 hour. And we can divide that with how many hours per day that that labor work. Let's assume 10 hours for 10 hours per day. And you notice that once this unit is cancelled out, so the duration of painting is 10 days. So this is how do we get the what we call the duration for all of the activity. It is not an easy job. So just imagine how many activity for a building project. Let's say we want to just develop one house. Okay, one house. There are so many activity involved. Maybe for simple house, just a very simple house, it could be maybe up to, if you want to split further, maybe up to 50 activities. So each of the activities you need to calculate using this concept, productivity. Let's say install door. Okay, there may be one or two door, maybe at least if you have 3 rooms, there will be 3 doors. You have bathroom door, you have front door, kitchen door, whatever. Just imagine what is the productivity rate to install one door. From that, then basically you can calculate just to install the door alone, not to mention to install anything. Okay, big thing when you want to construct a house. So using the same concept, productivity calculation, you can always calculate all the activity for each of the activity. If your assumption is correct, but then it is okay. We never know. This is planning. But what if, this is what we call planning. You plan, uh, you plan that your laborer can do 10 square meter in 1 hour. But in reality, later on, in the actual environment, we never know. You might get a lousy laborer. He can only do 8 square meter per hour. So that's why during construction, you need to monitor. What you need to monitor, one of the things is basically productivity. Productivity at construction site. When you monitor those things and you notice that this guy is not doing the job as productive as what we plan, then you expect that your certain activity will be delayed. So you need to do something. That is reflected in your scheduling. Okay, example. One example, estimate activity duration. Let's say we do have in a cut and fill, what we call cut and fill work, excess material normally being put into what we call the field section. Okay, field section. But then after we fill all the necessary place area, we might have what we call excess material. Okay, excess material that you cannot dump. Well, if the area is so big, then you just simply leave it on your area. But sometimes developer want everything to be clear, or you need to come up with the formation level. Maybe they will plan to do another project later on, so they do not want to do the cut and seal again. So we do have what we call excess material. This is what we call excess material. Excess material. Excess material need to be dumped or to be removed from construction site, and they need to be dumped to uh, allowable place. Maybe the allowable place, the dumping site, we call it dumping site, or maybe you can sell to other developer or other project site. Okay, whatever it is, you need to transport, let's say, 24 kilometers away. Okay, now you want to know how many lorry or dumper that you need, and how about the excavator that basically um, you scoop. Okay, you scoop the material onto the lorry. Okay, so basically you need these two machines, lorry and excavator. You need to know the output capacity of this machine. You can get the information from the manufacturer. Manufacturers such as Caterpillar do produce manual for all the machinery in term of booklet or whatever. You can get those things. They do sell the book actually. You can get online anyway. Okay, let's assume the lorry can do what in term of speeding. The lorry can speed 50 kilometer in 1 hour. That basically will reflect how long it will take to get into one point and then come back. And then when it is full, let's say slow down a little bit, and then to empty whatever amount that that machine can carry. And then the excavator can do 40 cubic meters scoop those material onto the lorry in 1 hour. Okay, so that will be the machine output. Okay, from that, for a lorry, from the calculation, we can get this information. 20 cubic meter in 2 hours. What is 2 hours? Where does this 2 hours coming from? It's basically from the cycle. Cycle meaning to say you go back and forth from to the dumping from and to the dumping site. Okay, 2 hours is coming from here. 30 minutes to fill in, 59 minutes to transport, 1.5 minute to empty, and then another half an hour to return. So basically, every machinery do not perform the same. So you need to get the right information. This is just an example. So this is how you get this amount. Okay, 20 cubic meter in 2 hours. All right. So you notice that the working hours per day is 8 hours. So 8 hours meaning to say you can only do 4 trips. That lorry can do only 4 trips. So one trip is 20 times 4 equivalent to 80. So this is what we call 80 cubic meter per day. All right. But remember how much material that we need to remove? 800 cubic meter. So meaning to say, as if we need to do 10 times, okay, 10 times doing the same thing again and again in 10 days. So the conclusion is that if we need to remove this excess material, 800 cubic meter, we need 10 lorry. 10 lorry if we want to complete the work in one day, just one day. But the issue is that, do we have that resources? If you do not have that resources, then you resort for 2 lorry only. But then the duration will be extended. But then if you limit to one lorry only, then your working days will be extended to 10 days. So this is how scheduling is being done. Okay, scheduling is depend very much on the resources that you use. From the resources that you use, you choose whatever, then only you can relate to the right duration. Okay, right activity duration. Okay, let's assume this is your what we call um, uh, what we call the activity for transportation only, 10 lorries for 1 day. And how about scoping those material into the lorry bucket? Okay, so in 1 hour, that excavator can do 40 cubic meter per 1 hour. In 1 day, 40 times 8 equivalent to 320. And if we need to scoop 800 cubic meter of volume, then how many machinery or excavator do we need? So basically we need 3 excavators. 3 excavator, 1 lorry, then only you can almost manage. This is not considering, let's say, that day rain will come. Then basically, in reality, this kind of situation will somehow delay our activity. But this is what we call planning. Okay, when you do planning, you cannot expect many things. You just expect based on whatever information that you get. Okay, this is what you can assume. All right. Okay, so that's how you get the duration for simple activity, duration for transport, access, soil. Okay, so basically the duration is 1 day. But remember, 1 day duration, and then there are so many resources that you need. 10 lorry, 3 excavator. So the issue is that can you afford to have those resources? If you cannot, then you have to play around with what we call duration of activities. All right, so that is the concept of getting the right what we call number of duration. Then the terminology. For the critical path, okay, critical path is the calculation method. We do have what we call early start. Early start, the pair is basically early finish. That is the pair. When you say you start early, you finish early. Then another terminology, late start. You start late and then for sure you will finish late. Late finish. Okay. And then the total float, we call it TF. But in Microsoft Project or Primavera, they simply call it total slack. And then free float. Free float. In computer programming, they call it free slack. They do not call it float. Okay. So we are going to define this thing in a simple way. Okay. In a simple way, instead of you can go into the definition, but I just want to give one example, simple example. Okay, let's assume uh, our class. Okay, our class time frame is basically at 10 a.m. and then 1 p.m. That would be the 3 hours. Okay, 3 hours class, and each hour of the class basically it run for 50 minutes only. Okay, in a normal face-to-face class, if you do have only 1 hour class, so basically you do not learn solid 1 hour. You only learn about 50 minutes because the other 10 minutes is for you to move around into another class or waiting for the other lecturer to come. That is the concept. Okay, in 1 hour, it is only, the learning time is only 50 minutes. So in 3 hours, meaning to say, if we are going to deduct each 10 minutes, then basically 2.5 hours only. 2.5 hours only. Let's say we do have scenario. If we start the class exactly at 10 and go straight without break, okay, without break, 2.5 hours, we should basically finish our class exactly at 12:30 p.m. So we do have a gap of what we call 30 minutes. That will be the extra time which basically considered as a break. Okay. If we do not take a break, then we start at 10 a.m. and then finish at 12:30. Okay, noon. That is 2.5 hours. What we call it, 2.5 hours. And this one is basically break, half an hour break. Okay, so then there is another scenario. This would be the first scenario, the first scenario. And then the second scenario, okay, what if, for instance, I wanted to finish the class at 1 p.m., okay, so I do not want to start at 10 a.m. Maybe I could not start at 10 a.m. So what is the latest? So you work backward, okay, you work backward, you start from the back, and then for sure, you know that the latest that you can start is 10:30 a.m. so that you can still complete within the time frame. Let's say maybe after this, after 1 p.m. or maybe at 2, you will have another class. So you need to have a lunch break, 1 hour. So we do not want to encroach into that time, let's say. Okay, so we do have two scenarios. And these two scenarios simply reflect, okay, the same thing. The amount of what we call learning hours is still 2.5 hours, except that the scenario is different. First, you start very early, then you are going to finish early. So this scenario, the 10 a.m., this is what we call the early start time. We can say in terms of time or in terms of what we call the date, whatever. So time, date, it could be weeks, it could be minute, hours, it's the same thing. Okay, so scheduling is all about timing. So this is what we call early start time at 10 a.m. and 12:38 p.m. is what we call early finish. If you start early, then you will finish early. That is what we call early start and early finish time. So the second scenario, if you start late, what we call this is what we call late finish. We work the other way around, the reverse. So in order to achieve the late finish, you also need to start late. Start late. So this is what we call late start timing. Okay, late start timing. So you notice that even for a simple activity like this, they do have early start date, early finish time, early finish time, late start time, and then late finish time. So just imagine if we do have a project duration of 2 years, and in that 2 years, we do have 1,000 activities, small activities. And when contractor are given a project, 2 years, when they do scheduling, you know what? Contractor actually can finish the project in 1.5 years, not exactly 2 years. But for the sake of what we call giving extra time to unknown situation, the contractor will stretch every activity so that it will fit into 2 years. If you just simply give to the client 1.5 years project scheduling instead of 2 years, where you are given 2 years, then you are killing yourself. You know why? Later on, when you encounter delays in certain activities, you simply have no room to basically to extend your activity, because the client will always try to squeeze the project timing to be completed as fast as possible. That is the mentality. Okay, so you are going to work under pressure, under a lot of pressure. So that's why you just simply say to the client that you, whatever it is, you can finish within 2 years, but the exact timing is basically you can simply finish much earlier. Okay, that is the concept. So meaning to say, there are certain activities which basically you can start as early as possible, whereas certain activity you can start as late as possible, or certain activity you can start in between, giving the time frame of the project 2 years, as in our concept. Okay, so you notice that we already define the simple definition of early start, early finish, late start, and late finish. How about the total float? You notice that in my drawing here, we do have half an hour here. This is half an hour, what we call free time. So that half an hour is basically the total float. What is the total float? Float is basically the free time, or what we call how much of time certain activity can be delayed. Delay in this context, meaning to say you can play around with that time, not delay in a negative context. We always thought that delay in a negative ways. Huh? But delay is basically a simple word that to what extent that you can stretch. Okay, you can stretch within the limit. That is what we call delay. Okay, so you notice that for scenario one, uh, we start early and then we finish early, meaning to say we do have half an hour free time, or what we call total float. Total float, for the sake of, let's assume that you cannot finish in 2.5 hours. Well, you can take extra 10 minutes, extra 20 minutes, or extra 30 minutes. That is the maximum amount. Okay, before the time frame of 1 p.m. All right, that is what we call total float. How about for scenario number two? Do scenario number two have free total float? Well, they do have also half an hour here, but the issue is that once you already use up the total float, let's say you start at 10:30, meaning to say your total float is zero by then, because you already use up the free time that you have at the beginning instead of at the end in scenario number one. Okay, so that is what we call total float. Well, now I want to define the word of free float. Let's erase this thing. Okay, free float. What is free float? Okay, free float, if you want to define free float, you need to split this activity. Activity 1, activity 2, make it bigger, 2, and then 3. Okay, so I split the class in every hour. Okay, I split the class every hour. Let's say the first hour, 50 minutes only. 50 minutes and then 50 minutes. I call it, this is A, B, C session. A, B, C session. And in between, I do have 10 minutes of break. 10 minutes. And here, okay, here we do have 10 minutes also. Okay, so this is 10 minutes. And then 10 minutes. Okay, C, 50 minutes. So we still finish at 1 p.m. We start the class at 10 a.m. Okay. So 50 minutes times 3 equivalent to 2.5 hours. Still, we still have the same, exactly the same amount of learning time. But then we split in these manners. Okay. For activity A, for first session, I start the class 50 minutes and then I give the break of 10 minutes before we start off B. Okay, let's assume another scenario. A is my session, then B would be a different lecturer section, C would be another lecturer section. So each of the lecturer has been given timing to enter into this Zoom room at exactly particular timing. So that lecturer expect that when time comes, then his session will basically start. So that's why for my session A, activity A, I can start at 10 a.m. and then finish 50 minutes later, and then I give a break, then the other lecturer can start. So this 10 minutes, this is what we call free float. Free float, and then free float. So free float, the definition is that the free time that once one activity have without encroaching the beginning of the next activity or subsequent activity. So between A and B, let's say I want to find the free float for activity A. So I must find the pair for A. The pair for activity A is basically activity B. The immediate successor of A is basically B. Okay, the immediate successor of A is basically B. So when do B start? B will start exactly 1 hour at 11 a.m. 11 a.m. Okay, I know that timing. So meaning to say, I must finish at 10:50 so that there is a break 10 minutes and then B will start at 11. So that 10 minutes is basically what we call the free float. Similarly, for activity B do have free float at 10 minutes, and then activity C do have 10 minutes of free float before encroaching into the final time frame. Okay, so that is the definition of free float. So I can play around. Let's say if I could not finish exactly 50 minutes, then I can extend 5 more minutes or even maximum 10 minutes. Okay, I can extend my time. But then for sure, I already use up the free time. There is no more free time. Then basically you need to start the class exactly at 11, etc., etc. That is the concept of free float in the context of activity. So in real project scheduling, we do have certain activity which basically do have a free timing with regard to the starting of the following activity. Example, let's say there is one activity, we call it A. Then there is one activity, we call it B. Then basically we call it C. A, B, C. The first activity, let's say 5 days, require only 5 days, whereas B require 10 days. When do C start? C can only start after 10 days. You notice that I put it dotted line. For activity A do have free float of 5 days. Meaning to say, A don't have to start exactly the same as the starting of B. A can be started a little bit later, as much as 5 days. You see, but B doesn't have the free day at all, because when B completed, C will have to start immediately. You see, unless B is what we call being extended or delay, then only we can see C will also have to be delayed. Automatically, that's how delay happen. When certain activity do not have a free time, but then delay still happen on that activity, then automatically it will push back the the subsequent activity. Okay, so at the end of the day, when those things happen, we will see it will impact the overall project duration. It will push back the project duration. Okay, well, I put it here, formula. Okay, formula is there. Well, if you remember the formula, then when you panic, for instance, you will forget about the formula. But later on, I will show you the easy way to calculate all those values. Okay. All right. Basic procedure to develop a network diagram. Doesn't matter whether you are using AOA diagram, AON diagram, and then subsequently PDM diagram. These are the steps. Okay. Steps are always similar. First, list out all activity from your WBS. Assign the time and resources. This is what we call calculate duration. Assign the immediate predecessor. This is what we call a link. What are the link between activities, the relationship, logical relationship. The link must be logic. You simply do not link activity without thinking about the logic. Okay, for instance, uh, you construct ground beam, then you construct the floor, the column, first floor column. Which one basically come first? Everything have sequence. Based on the list of information, develop logical network. Then you start um, connecting those activities together. Let's say you use arrow diagram. Okay, you connect those together. At the end of the day, for instance, you see, you will have a so-called network diagram. Okay, example. So this is the network diagram where every arrow should be connected. That should be the concept. Okay. Compute the starting and finishing time for each activity. Okay. Now the issue is that we want to know when is the project completion date. If you want to know, then basically you need to start calculating from each of the activity, looking at their relationship, then only you will get these values. Determine the critical path. Critical path is not singular. It could be multiple. Don't get confused. In our class, we only use a small example. So normally, multiple critical paths only appear just one. But then, in reality, it could be multiple, more than once. Okay, example of to develop network diagram, you need to have list of activity, real activity name for academic purposes. We just simply put ABC, duration. You need to know the unit, okay? And then predecessor, or you can even use successor. Immediate meaning to say, immediately after A, what come next, okay? Even though we know every activity are interconnected in one way or another, but we just want to know the immediate predecessor, exactly what come before and after. That is the concept. But we don't use the word immediate predecessor. We just simply use the word predecessor or successor. Okay, you notice that in this diagram, A, B, C basically nil or none. Doesn't have any predecessor. So we know that ABC basically is the starting of activity. So that's why this is A, B, C. This is AOA diagram. So we start with one node, then branches out the the arrow with the arrowhead. Similarly, and then mark the activity on the arrow A, B, C, and then later on put the duration. Okay, put the duration of activity. So let's say D. D, the predecessor of D is basically A. So we already have A, then we just simply connect the arrow and then close with one node. That is the concept, and then put D, and similarly. So E, see, E, the predecessor is B. So B is there, you just simply connect those arrow together. When you do that, step by step, you just go down the list step by step, and you will get the complete, what we call, network diagram. Then network diagram, you note down the activity at the bottom of the arrow, because this is AOA diagram. Then, well, for if you draw something like this is arrow, then you can have a compartment. But since the drawing is very difficult, so we just simply put box. This indicate what? Early start. This indicate early finish. This one is late start, late finish. So that's what we call legend. Early start, early finish, late start, late finish value. So we want to calculate, okay? The next step is basically calculating those values. How do we calculate? We are going to calculate using what we call forward pass and backward pass. So forward pass is the calculation from the left to the right. This is what we call forward pass. Forward pass. What to get is basically when you add early start plus duration, that would be early finish. Everything is basically plus. You plus, 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 plus. Example, okay? How do you do that? 0 plus 5 equivalent to 5. Then 5 plus 4 equivalent to 9. So that will be D. How about B? 0 plus 2 equivalent to 2. 0 plus 1 equivalent to 1. So now we already completed A, B, C, D. How about E? Okay, 2 plus 3 equivalent to 5 as one values. But you remember there are two arrow getting into this node, meaning to say this value is subject to whichever have the higher value among the encroaching arrow. 2 plus 3 equivalent to 5, 1 plus 6 equivalent to 7. Now, between 5 and 7, which one will go into this box? So, you have to read the, you have to know or understand the connecting arrow. So, I can only start when this E and F completed. E will complete in 5 days, whereas I will complete in 7 days. So, F will complete in 7 days. So, I can only start after 7 days. So, that's why the bigger value will be put into the box. So, when you do forward pass, you will take the bigger value. Bigger value meaning to say, bigger value of early finish to be the starting date for the following activity or subsequent activity. Then how about G? Okay, G, 1 plus 2 equivalent to 3. And now we already completed until D, E, F, G. The remaining basically H, I, J. H, I, J. You notice that there are 3 arrows going into the last nodes, and this value indicate the overall project completion. So we want to know that value. How to get that value? Okay, go through the calculation using each of the arrow direction. For H, 9 plus 4 plus 5 equivalent to 14 as one alternative. 7 plus 1 equivalent to 8. 6 plus 3 equivalent to 9. So now you see, we do have three values. Each one is the bigger value, or the biggest value would be 14. So automatically, you already answer one question in the exam. In the exam, we always want to know when is the project going to be completed. In 14 days. But sometimes we do ask in terms of date, not in terms of duration. Duration is very easy. Once you get this value, then you will answer the question. But in order to get the date, we must basically tell you when to start the project. Let's say we start the project tomorrow. Tomorrow will be Thursday. Thursday would be 19th of November. And then we set the holiday. Let's say Sunday is the holiday. Then how are you going to calculate? Well, you have to look at the calendar. Okay, when is the starting date, and then 14 days, meaning to say 14 working days, do not include the off day yet. Off day is the one that you set. Okay, is the one that you set. All right, that will be the forward pass. And then after you complete those things, you will copy this value into this box. Okay, you will copy, and then you will start doing your backward calculation. Backward pass to answer what? Backward pass is to get the value of late start, late finish, minus duration. The one that you put here is this is what we call late finish. Late finish, okay, of the duration for HI, whatever, that would be the latest that you can finish. Then you want to get the late start. Okay, so you have to work backwards. Okay, this is 14. Then you need to go back using the same arrow. Don't get confused. That's why when we draw, we do have arrowhead. Arrowhead is to basically to tell us where basically the connection between each activities. So now let's go back into H. 14 minus duration. Okay, 14 minus 5 equivalent to basically 9. For sure, when it comes from that direction, it will go back to the same amount or same values. Okay, and then 14 minus 1 equivalent to 13. 14 minus 6 equivalent to 8. So we already completed on H, I, and J for the value of late start. And then go back to D. 9 minus 4 equivalent to 5. By now, you already notice something. When those activity, when the value is coming from those line, for sure, when you go back, so you will basically copy back the same, exactly the same values. Okay, now let's do E. 13 minus 3 equivalent to 10. Okay, so now these notes, F and G going back into one node. Then how to calculate? So you calculate using the same concept when you do the forward pass. When you do the forward pass, you calculate on each activity, then you will get the early finish date to choose for the early start of the following activity. Now you do the same thing, exactly the same thing. 13 minus 6, okay? 13 minus 6 would be what? 7, okay? Would be 7. And 8 minus 2 for G would be 6, okay? Between 6 and 7, this one is 7, this one is 6. So now we take the lowest or the smaller value. We call it smaller value for the backward pass. So 6 is there, enter into this box here. And then how about C? 6 minus 1 equivalent to 5 as one value. How about B? 10 minus 2 equivalent to 8 as one value. How about A, 5 minus 5 equivalent to 0. So this 0 is the one that go back into this box. When you start with 0, you must come back with 0. That is the checking. So now, all of these, what we call early start, early finish, late start, late finish, has been filled. Okay. The next step would be basically calculate total float and free float. Calculate total float and free float. Okay, to calculate total float and free float, we are going to cover that thing when we go into AOA diagram specifically. This is just, this slide is just to give you the concept, okay, of network diagram. So later on, after this, we will zoom in into AOA diagram. Then we will go through the forward pass, backward pass, calculate all early start, early finish, and then total float and free float. Okay. So with that, we stop first for a small break.